Hello all, welcome to Tech with SAS. In this video, we will discuss various strategies to implement circuit breaker pattern in microservices. In the previous video, we discussed why we need this pattern and its importance. Also, the various states like the open state, closed state, and half open state. Like what are those states and why we need to bother about them, right? But in this video, I will not cover that. So if you haven't gone through that video, I would recommend that please go through that first, then continue here. I will put the link of previous video in the description below, and also you will be able to see that link in this video at top right hand corner. So let's start on the various strategies. So, first strategy is to implement the circuit breaker logic at the calling service. So, whatever logic you want to build, right, at how many errors you tolerate, like after how many threshold, how much threshold you want to tolerate, and then you want to stop calling to the provider service. So that you can have to configure in the calling service logic there itself. So that code might be embedded in the code base of a calling service. So whenever there is no issue at the provider service, it is up and running fine, then the call is passed through. But in case the this service is down, then the circuit breaker will kick in and open the circuit so that the next call which are coming from calling service is fail fast. So there will be no calls happening to the provider service. So in this approach, the logic of circuit breaker pattern is a part of code base at the calling service. So there is no impact to the provider service. This is like a most popular and convenient way of implementing the circuit breaker pattern. So now let's see the second implementation. That is called the proxy implementation. In this, the circuit breaker pattern is not part of either calling service or provider service. It's like a separate component, like it's like a side-by-side component. So that's why it is also called the sidecar proxy or sidecar deployment pattern. So in this, the code base is not impacted, like there's no code change to the calling service or the provider service. Both are independent from the circuit breaker logic, and this can be utilized for the multiple services. So here what happens, right? Whenever there's no issue, like both services are up and running, then it's a pass through, there is no issue. But whenever the provider service is down, the provider circuit breaker will already do a fail fast, so that there will be no further calls going to the calling service. So if you see that in this implementation, main benefit is that there is no code impact to any calling or provider service. So both are independent, and the component which we're deploying for this pattern, that is basically a separate component, a sidecar proxy. So this is like a good pattern. Also, when I will make a video on the service mesh, then it will be more clear. So yeah, so next implementation strategy is the uh, provider side implementation. In this implementation, circuit breaker logic is part of the provider service code. And why we need this? Because what happens that circuit breaker pattern will not kick in right away. Suppose there are three calls failing in each 10 calls, right? So it will not open the circuit right away. It will have some threshold, but at that time there will be inconvenience to customer, there will be response delays, right? So whenever we have very tight SLAs and we want to basically fail fast very quickly, at that time we use this pattern. So in this pattern, the code change is going to happen at the product service side, and there will be no impact on the calling service. So these are the three strategies which you can utilize when you are thinking to implement this pattern. So now let us see when we need this pattern and when we don't want to use this pattern, because Sometimes we keep contemplating, okay, whether I need this or not. So the main regions, like suppose uh, uh, you have a, remote service, right? That may be not in your purview. That can become unreliable. At that time, you must choose this pattern because you don't know, like that service may go down or may be failing or may be slow at some time. So it is good to implement in this scenario. And then second scenario is like when you want to make sure that the client is not impacted. Suppose the call service is down, but you want to make sure that response going is fine to the customer, so that there is no impact to response, or maybe you have some caching mechanism, right? Suppose so you can send a cache response to the customer back. So at that time, it's good to use this pattern. Now, when we don't need or we don't recommend this pattern, when there are like very few calls happening between caller and call. So suppose it's not like a very high volume service, so it's not required, right? Because if there are only few calls happening between the caller and called services, then it's overhead. And why we want to add more complexity into our code base, right? And second thing is that sometimes you want to basically use this pattern. I say that error handling pattern. Suppose you want to do some error handling using this. So this pattern is not for error handling. So please avoid that. Just it's used to basically make sure that the caller is not keep calling the call service in case that is down. So that is the main aim of this pattern. And then also maybe if you have a lot of functional calls or the in-memory calls and not many remote calls, right? Or no remote calls at all. So at that time, there's no need to use this pattern because this pattern is very useful when you have remote services and you have no control on that. So at that time, this pattern is very useful. So that's it for this video. In next video, I will cover the service mesh pattern. And also, there are some framework like we use this Linux 4J and the Netflix statistics pattern that are basically a coding part. So when I will start my coding series, I will cover each and every aspect of how can we implement it. So please subscribe my channel so that you get the notification about those videos. So thank you very much for watching. See you next time. Please leave any comments or questions if you have, and please subscribe. And thanks for your time.